This is a video on power sets, and this will be video 2 of the Set Theory 2 video series. So what exactly are power sets? I may have briefly talked about this in my previous video series, which I haven't looked at in a while. I'll have to review them, later just because I need to see what I covered and what I didn't cover. So basically, power set is not really that difficult of a concept to understand. It's basically you have a set, 7, 2, and 9. Let's just imagine those are our elements. And basically, we have to list all the possible subsets of that set. It can take a while, especially if you have like 5 elements. It takes a very long time to do. Imagine even more than 5. All the possible subsets you can come up with. One, we have the null set. That's important to note because the null set is a subset of A, and also is a subset of any set, including the null set itself. A subset are equal to. But anyways. 7 also subset, because this part it's a element, but 2, and if we take 7 by itself, it is part of A, but it's not all of A because 2 and 9 are excluded from A by the definition. So, and 2 is the same thing. It's part of A, but not completely, and contain. It's completely part of A, but it's not the entire set of A. Again, because it's missing the elements 7 and 9, which is the way we define the set. The reason why I'm speaking in more formal terms now as opposed to the previous video series is because this is going to be a more formal approach to set theory. So maybe it's probably a good idea to hold that off till later, but just know that there's going to be very formal ways that you have to define these things, especially when we get to topology. When we get to topology, we're going to be talking on very mathematically formal ways to make sure there are no confusions into what exactly is a space, because the conceptual idea of a space is well, we'll get to that later. Anyway, so 9, again, subset. 7 and 2 are subset. 7 and 9 are. 2 and 9 and 7, 2 and 9. And let's suppose we call set 7 to 9 also B. But notice it's the exact same thing as A. So B is a strict subset of, no, sorry, not strict subset. Subset are equal to A. Which could mean, it means either it is a subset or it's a subset or equal to. If it's a strict subset, meaning that it's not equal to, then we would write it as B. This little like it's a little like a it's kind of more like a stretched out C. There's a little slash at the bottom. That would mean that it's a strict subset. Now B is also isomorphic to A, which means exactly the same thing. And then of course you have your null set, which is A, or the null set's a member of A, which also implies that it's that the null set is a member of B also. Let me scroll that down. So again, the best way to rewrite this, actually, let me rephrase that. So B is the same thing as A, because it's isomorphic means the exact same thing. They have the exact same elements in both, and we can also say that B is an element of A. We can say a lot of different things about these two sets. Now, why all this examination of the sets? Well, because if we in the next couple of videos we're going to be talking more about why these principles work. Axiom of extensionality comes into play, but that again that's a little later on down the road. So basically, there are actually a lot of things you can deduce when the two sets are exactly the same. You can also say that B is a superset of A, A is a superset of B because they're the exact same things. They're equal to each other because we're going to talk about why they're equal. Let's just go over this now. If we have 7, 2, and not, actually I'm just going to not put that there. If B is a subset of A and B is also a superset and equal to of A, that kind of stands to reason that they're exact same thing, because there's really no way you can be a subset and a superset of the exact same set. That would mean that they're the exact same thing. So to recap what I just said, what the whole video is on. So there are power sets, which is basically all the possible subsets. Now, when you take the entire set, such as 7, 2, and we'll take like a subset of this. So 7, 2, and 9 is a subset of A. It's also the exact same thing. We're going to be talking about that a little later. But again, so the strict subsets here are, the null sets and all the elements that I've listed here except for 7, 2, and 9, which is also the exact same thing as set A. So again, so power sets are important to understand. There are a lot of things in theorems, which I shouldn't really use the word theorems, but a lot of logical statements that flow, and a lot of things you can deduce from the set if you look at the power sets, you can examine a lot of different properties of it. Topology we'll be talking about. We'll be talking about power sets when we get to there. And basically, there are a lot of rules that you can derive from listing the sets. There are a lot of laws, if you want to call them that apply. And so I guess this is a brief overview of power sets. I guess we'll see you in the next video.